Hello, and welcome to this lesson on errors. This is part of the course Python for Beginners. My name is Buddhika Karunaratna. I'm from the University of Morocco. As you have probably experienced by now, it is quite normal to get different kinds of errors while programming in Python. So in this lesson, we are going to get a formal introduction to some of the basic types of errors that we encounter. This is the regular color coding used in this presentation as well as all the presentations in this series. We can identify several types of errors that we encounter in programming. What we usually call as syntax errors, they are mistakes in using the programming language. Each programming language has its own syntax, and we should be very careful and we should write our programs correctly. And then we have runtime errors. Those are which occur when a script or a function is executing. These are sometimes referred to as execution time errors. And we will soon see some examples of these. And finally, we have logical errors that would not generate any error messages, but they would result in unexpected or erroneous output. So what are these syntax errors? Let's take an example. Look at this print example. We are trying to print the string hello world to the console. Did you notice something wrong? You can take a moment to observe. So what will happen if we run this code? You can see that it generates a syntax error. We were trying to print a string value and Python was expecting single or double quotation marks. But we mistakenly had one quotation symbol missing at the end of the line. Because of that, Python is complaining about a syntax error. Now we have some idea of what a syntax error is. Now let's look at runtime errors. Runtime errors occur whenever syntactically correct Python code results in errors at the runtime. So there will be an error message telling us what went wrong. And it is important to know that whenever a runtime error occurs and it is not handled properly, your Python program will terminate after that point of error. That's a problem. Meaning the program will not continue to execute and you will not be able to get the expected task done. There are many types of runtime errors in Python. We will look at some of the common types in the next few slides. Let's first look at what we identify as a name error. A name error usually occurs when you try to reference a variable that has not been defined previously in the code. So we have an example. In this example, you see a variable named number with value 10. Then we try to print the value of a variable named num num. Notice that our original variable name was number, but we are asking Python to print the value of a variable name num. Therefore, Python is complaining about a name error. And it says name num is not defined because it was not previously defined. So remember to avoid this kind of mistakes. If you get a similar error when you go ahead and do some programs, now you can look for some error which is probably related to naming and referencing variables. Now let's look at index error. This happens when we try to access a value from a sequence, but the referenced index is out of range. We have an example. So here, my list only has 3 items. And the index of my list is ranging from 0 to 2. But we are trying to access the item at index 10, which is not available. So that is why Python is raising an index error. It is complaining that there is no item at the selected index. Moving on to type error. So this kind of error occurs when we try to perform an operation on variables or objects of inappropriate type. So at this point, you understand what the type of a variable is. So in this case, we are causing a type mismatch. In the example given, we are trying to perform the plus or addition operator on a string and an integer. Therefore, Python is complaining that it can only concatenate. So what is that? What is concatenate? It means to join a string to string, but not any other data type. In this case, we are trying to do that with integer. This is just one example, but you may encounter many other similar situations when you program with Python. Now let's look at what we mean by a value error. A value error occurs when a built-in operation or a function receives an argument that has the right type but an invalid value. So in this case, in this example, we are trying to print the value of an integer, but passing the string value hello to the function int, which is invalid. So that is why Python is complaining about a value error. Lastly, we will identify what is known as an import error or a module not found error. So in this example, we are trying to import a module named new module, which does not exist. Therefore, Python is raising a module not found error because it's not there. Similar error could occur if you try to import something, some function inside a module. The module could be existing, but that function or the part that you are trying to reference within that module does not exist. In such cases, Python will generate this error, which is module not found error. As we have discussed before, when a runtime error occurs, the program will stop immediately if the error was not handled properly. Therefore, you need to plan carefully to catch any of these possible errors during runtime and handle them. That way, you can keep an uninterrupted execution of your program. In the next section, we will see how to handle such situations. The try except structure helps us to handle possible runtime errors. It does not mean that we can prevent the errors. Instead, it creates a safe passage for the program in the case of a runtime error. We can basically identify 2 blocks. They are try and except in this structure. We can put the so-called dangerous code into the try block. That means you are anticipating an error in that section of the code. That's why we call it the dangerous code. In the case where the error actually occurs, the program jumps to the except block and executes what's inside that block and moves on with the program. However, notice that if we did not use this error handling structure, that program will terminate as soon as the error occurs. We don't want that situation. We want to avoid such situations. So that's why error handling is very, very important. Now we look at a simple example of this try except structure. In this program, we are expecting a number as input from the user. Once some input is provided, the program will try to convert that into an integer value. Notice that it is actually the risky operation. Why does it become risky? Because we cannot guarantee that the user will provide a number. For example, the user can provide a string or just input nothing at all. So in such case, the program will have a problem converting anything other than a number to integer. In normal circumstances, the program will complain about this issue and immediately terminate. But in our example, in such a problematic situation, the program will jump to the except block and assign the value -1 to the variable num_val. So it will prevent ungraceful termination of the program. This is how you use try except structure to handle possible errors. That is the end of the lesson on errors. I recommend you to try out those examples that were provided in this section. In the next section, we will discuss about files and how to handle files in Python. Thank you.
Hello everyone. Welcome to the session on Python file handling. I am Dr. Sunima Ratnayaka from the Department of Computer Science and Engineering, University of Monaco. In this session, I will introduce you to a few basic concepts related to file handling in Python and some functions that we can use to read and write to files. By now, you should be familiar with our color coding system, which we have been using throughout this course to highlight important points and categorize various terminology and different topics related to our lessons. Here is the outline of this lesson. First, we will talk about files in general and why do we need them. Then we will look into the Python commands relevant to file operations such as opening, reading, and writing files. Before we start talking about files, let me do a quick recap on the main components of a computer system, which you learned at the beginning of this course. This will help you understand the role of files in a computer system. Our modern computers mainly consist of 4 main subsystems, mainly the central processing unit, the memory subsystem, the input-output devices, and the storage devices. So far, the lessons you have learned in this course involved CPU, memory, and the input and output devices. The main memory in the system is volatile. In other words, the main memory is a temporary memory where the contents would be deleted when we switch off the power. Therefore, the work we do need to be saved in some kind of persistent storage so that we can use that later. The persistent storage is also called secondary storage of a computer. A typical secondary storage devices used today include hard disks, solid state devices or SSDs, and pen drives. You may think of few other storage devices as well. Data is stored in these secondary storage devices as files. There are many types of files which we often differentiate using the file extension at the end of the file name. For example, you can see a list of file types shown on the slide. Commonly encountered file types include text files, PDF files, Word files, Excel files, image files, and video files. There are thousands of different file types. The extension of the file is the last part of the file name, which comes after the dot symbol. For example, text files can be identified by the extension .txt. On the top right section of the slide, you can see an example text file. The name of the text file is myfile and the extension is txt, which indicates that myfile is a text file. Text files are a very simple file type, and they consist of a sequence of lines that contain only text characters such as letters, numbers, and other special characters. Our example text file shown here, myfile.txt, has 3 such lines, as you can see. The 3 lines are: I like Python programming, I am learning Python with UOM, and Python is easy to learn. In our lesson today, we will learn file handling with text files as an example. Before reading or writing to a file, we need to open the required file. To facilitate opening files, Python provides us with a function named open. Open function opens the required file and provides us with a special pointer called a file handle. A file handle is a special variable that links our Python program to the file and helps us perform various file operations. While opening files, Python allows us to specify a file opening mode, which indicates the purpose of opening the file. For example, we can tell Python that we want to open a file only for reading, for writing, or for both reading and writing. Here is how we can open our text file myfile.txt using the open function. As you can see, there is a special variable called fhandle, which is the variable where the file handle is going to be assigned after calling the open function. To open a file, you must provide the name of the file that you want to open as a string. In addition to the file name, you can also optionally specify the file opening mode. In the first open example, we have only given our file name as the input parameter to the open function. If we do not specify a file opening mode like shown in the example 1, Python automatically assumes that we are opening the file for reading. In the second open example, we have explicitly specified R as the file opening mode in addition to the specifying file name. Therefore, the file will be open in the read mode. Essentially, both example 1 and 2 opens the same file named myfile.txt in the read mode. After opening the file, we can read the file contents. In this example, in the first line, we open our text file myfile.txt without specifying a mode, which will result in opening the file in the read mode. The open file will be assigned to the file handle named fhandle. Then in the second line, we use another Python function called read, which is used to read the contents of the open file. When calling the read function, we have to tell Python from which file we want to read. This is done by calling the read function for a specific file handle. In this example, our Python file handle is fhandle, and we can call fhandle.read to read the file associated with the fhandle file handle. Read function reads the whole file and returns us all the contents of the file as a sequence of characters. This returned content can be now stored in a variable as a string. In the second line, we are storing the contents of the file read using read function in a variable called fcontents. The contents can be processed like any other string variable. In our example, after reading contents into the fcontents variable, the third line prints them. This is the expected output of the example code shown here. The contents of the file myfile.txt will be printed on the terminal as shown. After we are done with the file operations, we should close the file we opened. Python may automatically close any open file when the file is reassigned to a different file handle. However, it is a good programming practice to close the file after its use. We can close any open file by using the close function as shown in the example. In the early example of reading files, we used the read function, which reads the whole file at a single go. We can also ask Python to read a file line by line instead of reading everything at once. This can be achieved by using readLine function. After opening the file, we can call readLine with the relevant file handle to read the file line by line. In the example shown, we print each line read from the file. You may wonder how Python determines end of a line. For example, readLine function needs to locate the end of each line of the file to read the contents line by line. In Python and most other programming languages, the end of each line in a text file is indicated with a special hidden character called the newline character. The newline character is written with the symbols \n and is placed at the end of each line. Since it is a special symbol used to indicate the end of the line, it is not visible in the text file. However, while printing sequence of characters, whenever a new line is encountered, Python goes to the next line before printing the next character. In our text file, the placement of new line character placements are shown in the slide. Now that we know how to read files in Python, let us learn how to write to a file in Python. To write a file, we have to open the file in the write mode. To do that, we can specify the mode as W while calling the open function. Once opened, we can use the function write to write a given string to the file. In the example given, we have a string called myString, which contains the two lines, Python is great and file handling is so easy. You may note that to separate the two lines, we have used the new line character \n after the full stop of the first line. As usual, we close the file after writing. In this lesson, we learned how to open files in different modes, such as read mode and write mode. There are many other opening modes which you will learn in our next series of Python lessons. When opening files, we need to specify the file name like we saw in the example. This will only work if the file is located in the current working directory. If we want to open a file which is located at the location which is different from our working directory, we should give the full file path as the file name, as shown in the line 4 of the example shown in the current slide. Whatever the mode that you try to open the file with, you can encounter a situation in which the file you are trying to open does not exist in the specified file path or in the current directory. In such a situation, depending on the file opening mode, Python will take different actions. If the file mode is read, Python will show an error saying that the file cannot be found. If the file open mode is W or write, Python will create a new file named with file name specified if it does not already exist. Alright, so we have come to the end of the lesson on Python file handling. In this lesson, we learned the importance of files and the roles files play in a computer system, and how to open, read, write and close files with Python. There are many complex tasks we can do with Python file handling, which we will be learning on advanced Python courses we'll be offering after this series of lessons. Thank you.
Hello, and welcome to this lesson on Python libraries. This is part of the course Python for Beginners. My name is Buddhika Karnaratna, and I'm from the University of Moratuwa. In this lesson, we will introduce Python libraries in general and look at some commonly used libraries. This is the standard color coding used in the presentation. This is consistent with all the lessons in this series. So what is a library? I believe all of you have been to a library in your school, in your hometown, or even at your home. A library is usually a collection of books, or is a room where many books are stored so that we can read them when we want. In the world of programming, we use the term library to mean a similar thing. A library, in the context of programming, is a collection of pre-compiled codes that can be used in the programs that we write. These codes help you to get some specific and well-defined subtasks done. You can use them whenever you want, repeatedly. They make your programs much less complicated and save your time on repeating the same thing over and over. Now let's look at what a Python library means. A Python library is a collection of what we identify as modules. In simple terms, a Python module is a set of lines of code written for a specific purpose. You can get some specific task done using a given module. You can use this module repeatedly in Python programs without having to rewrite the same code at each usage. This makes your life easier as a programmer. The libraries are made publicly available for anyone to use. So if someone is running into a problem or identifies an error within the library, that person can report about it. In that way, the problem can easily be fixed in the original library so that everyone using it can get the correct and expected output. Essentially, the libraries and modules are shared resources. Now let's look at a simple example. Say we need to find the square root of a number. Very simple thing. So how would you do this in Python? What we can do is we can use the exponentiation operator, which is given by the double asterisk symbol, and raise the given number to the power of 1 over 2, or in other words, half. That will give you the square root of the number. What you can see on the left-hand side is that method. On the other hand, you can use the built-in math module in Python to do the same thing. That is what you see on the right side. In that case, first, you have to import the module math using the reserved word import. Then you can call the function sqrt, which stands for square root, which is part of the math module. That way, you don't actually have to write the logic of calculating the square root of a number. You are just calling a function. It is just a matter of importing the module and calling the corresponding function. This is just a very simple example. The math module itself has many other such functions to make calculations much easier. Then there are many other such useful libraries and modules available in the Python ecosystem. You can explore them as we progress in this program. In the previous section, we imported the whole math module, which has many functions, but we wanted just one function. So in this case, we can selectively import the functions that we need, only import the required function. Hence, by using the reserved words form and import, we can import only the function sqrt from the math module. That is what you see in this code snippet. Now we move on to introduce Python standard library. Python's standard library has built-in modules that provide access to basic system functionality like inputs and outputs, network access, and so on. The standard library consists of more than 200 core modules, which provide convenient access to main functionalities of the Python language and the environment. All the capabilities that are supported by the standard library contributes towards making Python what we call a high-level language. To use a high-level language, we do not need to have in-depth details of what's happening in each action. A high-level language provides a convenient and easy-to-use interface for the programmer to get the required task done. The math library we saw in the previous example is from the Python standard library. Now we move on to look at some other Python libraries. There is a wide variety of libraries available for Python. They make Python such a powerful tool so as to become the most commonly used programming language in the world today. And that is not an exaggeration. Python libraries provide us with a vibrant set of capabilities, developing nice graphical user interfaces for the applications, working with numbers, working with data, develop prediction models are only a few of such capabilities, and there are many more. Here we briefly introduce a couple of commonly used Python libraries for graphical user interface development: PyQt5 and tkinter are two popular such libraries. PyQt5 is actually a visual framework that allows drag and drop of GUI components like buttons, labels, text boxes, and etc. As such, it provides a convenient framework for GUI or graphical user interface development. tkinter is also popular for developing desktop applications. NumPy is a vastly popular Python library for numerical computations. It consists of a wide collection of built-in mathematical functions to make the complex calculations more efficient. NumPy can deal with large and multidimensional data sets. And moving on, SciPy is a well-known Python library for scientific computations. It actually uses NumPy for numerical calculations, and on top of that, provides modules to represent scientific concepts. Some of the capabilities include statistical modeling and signal processing techniques. Matplotlib is a famous Python library for plotting, as the name suggests. It provides a wide range of capabilities for plotting numerical data. Some of the graphical representations include graphs, pie charts, histograms, and scatter plots. It is a very useful tool when working with data, especially for different kinds of visualizations. The Pandas library enables data manipulation and analysis. This library is especially helpful when managing large and unstructured datasets. Pandas provides data structures and operations to manage such data. Machine learning, deep learning, and artificial intelligence are quite hot topics currently in the field of mathematics and computer science. The basis of such techniques are statistical models. You will actually get introduced to these cutting-edge technologies as you progress in this program. Python ecosystem provides a wide range of capabilities in this line of work. scikit-learn and TensorFlow are only two common Python libraries which support machine learning and deep learning. And then there is many more such libraries available for Python. And that brings us to the end of the lesson on Python libraries. I hope you learned something new. Thank you.
Hi there. Welcome to our introductory Python course, Python for Beginners. I hope you have enjoyed the course content so far. I also hope that you have written some Python code and gotten your hands dirty. I'm Omega Silva, and I am a software solutions architect for a leading IT services provider in Sri Lanka. And I plan to discuss about writing clean code with you in this lesson. We have broken down this lesson into 3 parts. In part 1, which is this session, we discuss about what clean code is, why it is important for us developers, and the problems that clean code solves. In part 2 and part 3, we would discuss about techniques in writing clean code with Python, looking at a few samples. Before we dive into our course content, let's spend a moment in understanding the color coding that we have used in this presentation. If you see red color text, that means it's very important. So pay your fullest attention. Blue color text is also important, so don't miss out on them as well. We have used green to indicate terminology and terms. And purple is essential yet off-topic content that helps us communicate the message clearly to you. Now that you understand the color coding that we have used throughout this presentation, let's dive into the subject matter, which is writing clean code. I know you are keen on understanding what clean coding is, but before we go there, let's look at a few other things that might help develop that understanding. So, first of all, let's look at how a code base evolves over time. As this diagram indicates, when you write code, you would start with a few set of requirements, and you would implement these requirements in your favorite programming language, let's say Python. And once you're done implementing, you would test your code to make sure that the code works as expected. And if the code works as expected, you would obviously consider this as a stable piece of code. And you would mark it as a stable version using version controlling. You may use something like Git for doing that. Now, the process doesn't stop there. More new requirements would come into existence. Similarly, new enhancements to the existing code base, a few bugs that you find along the way might have to get fixed. And in doing so, you would add new code, you would change existing code, and perhaps you might even remove existing code. Once you are done with that, you would again test the code to make sure that it's stable. And if it is stable, you would mark it as a stable version. And the cycle continues. One important thing that you need to understand is writing code doesn't always mean that you're adding new code. It's a mix of newly written code, the code that you change from the existing code base, and in certain cases, the code that you remove as well. In my experience, adding new code is always easy. The reason being, when you write new code, you exactly know what you need to do. That's in your head. And you just convert the understanding that you have in your head using your favorite programming language into software. Easier. However, when it comes to changing and removing code, you have to have a thorough understanding of the existing code base. Unless otherwise, you might change the code base and the code would break, as in the code would not work. Now we understood that code bases change over time. Let's have a look at some code bases of famous software tools that we use on our day-to-day life. Mind you, all these code bases that I have listed here, they contain millions of lines of code, and they are still active, as in developers are working on changing, adding new code up to this particular point of time. If you look at Google Chrome, they started off in 2008, and they have done 96 releases so far. If you're wondering what a release is, that's where the development team does a significant amount of code changes and additions in implementing new features, enhancing existing features, or fixing defects, test the code base, and release to the general public for use. Python 3, again, started on 2008, 100 releases till date. Linux kernel, 104 releases, and the pattern continues. Now, this proves that code bases grow over time, as in the lines of code in a code base increases over time. It also proves as long as the software is being used by its user base, the code base continue to change over time. All right. So code bases exist, but who do the coding? It's the development team. Now let's look at how the development team or the project team changes over time. You would start off with a relatively smaller team with a few requirements at hand. But as time continues, you would get more requirements, more enhancements, and perhaps defect fixes. And to do that, you would have to get new team members. Now, even though you don't increase your team size with the new team members, your existing team members who understand the code very well, the existing code base very well, may decide to leave your team. And you don't have any other option than to fill those positions from new team members. Now, this creates an interesting dynamic. Now, you have your experienced team members as well as new team members who have no clue about the existing code base. But the features that you have to implement, the enhancements or the defect fixes, they still have to be completed on time. And to do this effectively, your new team members have to understand the existing code base. So usually what happens is the existing team members who have an understanding of the code base, they set up a session with these new team members in trying to explain in the code base, educate them about the code base, and later they can take it on their own and go through the code base to improve their understanding. Now, when such a session is in progress, when the existing team members and the new team members get together with the pure intention of improving the understanding of the code base, if your code is really difficult to understand, this would be the vibe of that session. The team would spend a lot of time. In fact, they would waste a lot of time and come out of this session without a good understanding of the code base. Ultimately, the team will be frustrated and tired, and no one would properly understand what the code does. This is not a healthy situation for a project to continue, because if the developers do not understand the code properly, they cannot apply the new changes or introduce new features properly. So how do we overcome this challenge? How do we make sure that the entire team understands the code base properly and they come to that understanding with ease? I'm sure most of you have guessed the answer by now. You have to make sure that you write clean code to ensure that the code is understandable and it can be easily modified, so that even the existing team members or the new team members would have a good time and they can easily, efficiently go through the code and understand the code base. What does clean code mean? Now, the first thing that I did when I was learning clean code is to Google what clean code is. And I found a lot of results, a lot of definitions. But one thing that caught my eye, and one thing that I remembered up to this particular date, is the definition given by Grady Booch. Grady Booch is a pioneer in software engineering. He has been the leader in developing unified modeling language. We call it UML. And he has contributed a lot to improve software engineering as a practice. So Booch says, clean code is simple and direct. Clean code reads like a well-written story. Clean code never hides the developer's intent, but rather is full of crisp summarizations and straightforward lines of code. So, what does this mean? If you analyze the definition on clean code provided by Booch, he highlights 4 major qualities of a cleaner code base. He says a cleaner code base is simple and direct, and it has a nice flow like a well-written story. As when you read your code, it's like you're reading a story. There is a very nice flow that allows you to understand it better. It doesn't hide the developer's intention. As in, when you read through the code, it is very clear what the developer wanted to do with those lines of code. And it also nicely summarizes the developer's intent without any ambiguity, as in it clearly summarizes. So if you have these qualities in your code base, your code base becomes easier to read and understand, easier to change, easier to test what you wrote, and it also becomes easier to add new features by adding new code and minimizing the changes that you have to introduce to your existing code. The 4 qualities that Booch highlights are the essence of writing clean code. As you can see in this diagram, where it has nicely summarized those 4 attributes, which are readability, maintainability, testability, and extensibility. These are the 4 main qualities that any developer would have to align their mindset when you say that you're writing clean code. Now, in this lesson, we would understand how to write readable code, the techniques with a few examples in Python, but we would not go into a deeper end on the maintainability, extensibility, and testability. However, towards the end of this session, we will discuss about those 3 in a little bit more detail and provide a few references so that you could study about these on your own. One important point to understand is applying these qualities to your code means you do it at the very first time that you're writing your code. Why? In my experience, where I understood my code the most is at the point of writing the code, because I'm thinking the logic and I'm converting that logic into code. A couple of days later, when I look at the same code, I have to put an effort to understand the code. And if I wait longer, I would get bombarded with more work, as in different priorities or critical things that I have to look into. So I could completely forget to, change code or clean code. So one important thing to take note is that applying these principles or qualities to your code has to happen at the very first time that you're writing your code. This brings us to the end of part 1 of this lesson. So let's summarize what we learned so far. We understood that code bases change over time. We also understood that the developer teams who work on code bases also change over time. And the code we write should be easy to understand, not only by the team members, but by the authors who wrote the code, easier to modify, easier to test, and easier to extend. And if we do a good job in applying clean coding techniques, we should be able to align our code with those qualities. And at the same time, we should be able to help the team who continuously change with new team members to understand the code in a more easier manner. I hope you have understood and enjoyed the concepts that we discussed during part 1. And in part 2, we are going to discuss about writing readable code in Python. We would use some scenarios and examples and sample Python code as well. I hope you are excited for part 2. Until I speak to you in the next section of this lesson, have a good one. Hello. Welcome to our introductory Python course, Python for Beginners. I'm Omega Silva. This is part 2 of our 3-part lesson on writing clean code. In this session, we are planning to focus on readability of code. We are going to look at an example, look at some code, and try to understand techniques in writing clean code. Before we proceed, let's have an understanding of the color coding that we have used across this presentation. If you see red color text, that means they're extremely important. Blue is also important, so you have to pay attention to them as well. We have used green to indicate terms and terminology, whereas purple indicates slightly off topic, but content that is required to make a point. Now that you understand the color coding, let's dive into this session's content. Let's try to recall what we learned in part 1. We discussed how a code base changes over time. We also discussed how a software development team changes over time. Through this, we came to understand that if your code is not clean, it is very difficult to read and understand, and therefore change your code. We also looked at the definition Grady Booch provided on clean code, and we identified the 4 main characteristics of clean code. These are the 4 main qualities of a clean code base. As developers, we should always get our mindset aligned with these qualities so that you could adhere to them while you're writing code. Delaying to clean up code is not a good idea, simply because other priorities may continue to keep the code cleanup tasks further delayed, and it will lead to an unhealthy code base. Out of these 4, we are going to focus more on readability. These 5 techniques are selected out of many because these are the basics of writing clean code. They're simple to understand, yet if you keep on applying them when you're writing code, your code readability will improve significantly. In today's session, we plan to discuss about the first 2 techniques. To discuss these techniques in more details, let's look at an example. We have selected a scenario of lending a book to a member from an online library management system. The diagram that you see here, which explains the scenario, is known as a flow diagram or a flow chart. These diagrams are used to discuss a decision-making process and the actions that happen after the decisions are being made. The black color circles, they represent the start and the end. The square shapes, they represent the actual items, which can be done either by a human or could be done by just code. The diamond shapes, they represent the decisions that are made along the way. Now, I recommend that you pause the video and read the text on each of these shapes so that you could follow my explanation of the scenario in a more efficient manner. The scenario starts with a user of this online library management system requesting to lend a book. Once the request is being made, the system checks whether the user is an actual member, and if so, whether the member has already lent 2 books, and if not, whether the requested book is available. Then it calculates the requested book's new return date, and then assigns the book to the member, assigns the new return date, which we call as the checkout process. If any of these validations fail, the system would send a message to the user why the book lending process could not be proceeded forward. And after that, it ends the process. Let's look at a Python function which implements the logic which was described in the flow diagram that we looked at earlier. Again, before we proceed with the explanation, please pause the video. And if you don't recall the flow diagram, go back and look at the flow diagram again and read the code that you see on the screen so that we can can follow the explanation in a more efficient manner. Also note, when I am explaining the code, I am not reading out the underscores on function names, the variables out loud. The method name here is lengbook, and it obviously takes two parameters, MID and BID. We don't know what they mean, but let's follow along. The first line that we see in the method is a validation, an if condition, which calls a function check DB member, and it passes the MID. Now, trying to recall the flow diagram that we looked at earlier and trying to relate this to the code, I can guess this function may be validating the member ID to see whether the member is actually a member. And if it is valid, it checks whether the member has lent two books for the time being. And it seems the getBook method, which takes the member ID, returns the books that the member has already lent. Thereafter, it checks whether the book is in the database. So the name suggests check DB book. But again, relating this to the flow diagram, this seems to be the function which checks the book's availability. After that, if all three validations are successful, it captures or rather calculates the return date. Now this is very clear because the variable name used, it is actually the return date. So it gives me an indication the logic highlighted is about calculating the return date. And there is a function that's called update DB book checkout. But the word checkout indicates this is the last step of the book lending process where the checking out of the book actually happens. The else structures, they are self-explanatory because of the messages that it prints. They are essentially providing a valid reason for the user for not proceeding with the book lending process. When we looked at the flow diagram, the logical flow, the decisions that it makes, the actions after the decision making, they were quite clear. But the Python function, which implements the same logic, seems a little bit difficult to understand. Categorically speaking, this difficulty of reading code is due to two main factors. The first one, which is very important, is not using proper contextual names for both variables as well as for functions. The second thing is this function does too many things. Let's look at a few examples. Starting off, the two arguments that are passed, it does not have self-descriptive meanings. We have to guess along the way what MID and BID means. The same continues for function names. Check DB member. Even though this is a valid function name, it does not tell what the function does and what it evaluates. This is a little bit descriptive because books and the greater than two is easier to understand because we already had a look at the flowchart. The same argument goes here, not a good name for this function. Now this calculation here, it is a little bit descriptive simply because the variable that's used, its name is return date. And we can easily relate this calculation to the step in the flow diagram where it calculates the return date. And these else conditions, they are self-descriptive because it is a message in plain English that gets printed. Now let's try how we can improve this method by doing two things. First, let's try to introduce some meaningful names. Then let's have a look at how we could break this method into more manageable functions. I have listed down the variables and the functions that we saw in the lengbook function, their purpose, And I have suggested some better names. So let's look at the first two, MID and BID. Obviously, these represent the member ID and book ID. And if we name them as such, as member ID and book ID, they don't need any explanation at all. It is quite clear to the reader what they represent. Let's look at the method name, check DB member, which validates whether the user is already a member, can be easily named as is library member, which is self-descriptive on the functionality that it performs. The same goes for the rest of those variables and methods or the functions. Out of all these, I need to highlight row number 7. Now, this is a variable where its name is a single letter. These kind of variable names are not descriptive at all, and you have to put a lot of effort in trying to understand what these variables mean. Therefore, this is something that you have to avoid in all cases. Perhaps one exception for such variables is when they are being used as loop counters. For example, in a while loop. Apart from that, make sure that you don't name variables with a single letter at any cost. This is the same lendBook function with the improved names replaced with the previous names. Starting with the arguments, member ID and book ID, which are self-descriptive, and moving on to the functions. As you can see, is library member and get book lent to date. They actually represent by the names what those functions actually do. And it's almost like asking a question. The if condition asking a question is library member and pass the corresponding member ID. And this condition or the validation here, it does not represent the number 2. Instead, the numbers have been assigned to a variable, which is again carrying a meaningful name. The max books to lend explains what number 2 is, and same goes for lend time period, which represents what number 14 is. And that is being used in the return date calculation. As you can see, simply by improving what variables and functions are named, we have significantly improved the readability of the code. Even though we have not changed the number of lines in the method, when you read along, it is quite easier to understand what each and every line represents. The second factor which impacts the readability of the function is that this function does too many things. For example, this checks whether the user is eligible for a book to be lent. It checks whether the user is a member and whether the member has lent more than 2 books. Then it checks the book's availability, calculates the return date, checks out the book, and in cases where the validations fail, it prints messages so that the user understands what went along. So let's try to break this function into more manageable pieces. And I would like to take this piece of logic where it checks the user, whether the user is eligible for a book lending. And secondly, the piece of logic which does the return date calculation, which could be reusable within the system as well. What you see on the screen is a new function that we have created by extracting the piece of code which did the member validation or checking the member eligibility. As you can see, since this is a function, this returns something out. So it is as if the function is member eligible for lending. It's like asking a question from the function, is this member ID eligible for lending? And the function says true or false. The is eligible variable is set to false, and only if the two conditions or the two validations are successful, it is assigned to true. The second function that we have extracted out is the calculation of the return date. Again, the function name is self-descriptive, get book return date, and we have moved this particular variable inside this function as well. And the rest is the code which is responsible for calculating the return date. This is what you get after applying better names, and instead of the elaborative code that we had in the function, we extract out the logic into other smaller manageable functions. The number of lines of code has been reduced, and the code is much more readable compared to what it was. So if you read along, it's like we are reading a particular description written in English. It's first of all, it's asking if is member eligible for lending, and passes a member ID, and the function says true or false. And depending on that, if the member is eligible, then it again asks the question, is book available? Passing the book ID. And if it's again true, if the function says true, then the logic knows it can move into calculating the return date and checking out the book. And that's exactly what it does. The return date is being calculated from the get book return date function. And then you have a method for checkout book. So compared to where we started, isn't this much more readable? This actually reads the code as if you're reading a story or a description about the flow diagram that we had a look at. Before we move on, I would like to emphasize what these two new functions do. The is member eligible for lending function, it only validates whether the member is eligible for a lending. It does one thing, and hence this is a function with a single responsibility. The same goes with get book return date and is book available. There are also functions with a single responsibility where one checks whether the book is available and the other calculates the return date of the book. This brings to the end of our session today. Let's summarize what we have learned. Out of the 4 qualities of clean code, we did a deep dive on readability. We've identified 5 critical techniques of writing readable code, and we deep dive on using meaningful names and writing functions with a single responsibility. And through an example, a flow diagram, as well as a function which was badly written, we applied these 2 techniques and looked at how the readability of the function improves. In the next part of this lesson, we are going to deep dive on the rest of the 3 techniques that we did not discuss during this session. Before that, make sure that you again go through this lesson, understand the flow diagram better, understand the code example better, and look at how these techniques help improve the badly written method to a much more readable method. And also, if time permits, get your hands dirty by applying these techniques into the code that you write. Until I speak to you on our next session, have a good one. Hello. Welcome to our introductory Python course, Python for Beginners. I'm Omega Silva, and this is the final part of our 3-part lesson on writing clean code. In today's session, we plan to continue on understanding how to write readable code. And we are planning to discuss 3 techniques on avoiding copy-pasting code, avoiding deep nesting, and how to comment responsibly. Before we proceed, let's understand the color coding that we have used. As you may already know, red text means important points that we want to include. Blue means also important points. Green text we have used to indicate terms and terminology. Purple is content which are slightly off topic, yet important to cover certain concepts. Now you understand our color coding. Let's start today's session. Let's recall what we learned in part 2 of this lesson. In part 2, we looked at 2 techniques of writing readable code, which is using meaningful names and writing functions with a single responsibility. To discuss these techniques in details, we had a look at an example taken from an online library management system, and we looked at a simple flow of lending a book. We had a look at a Python function which implements that logic that we saw in the flow diagram. And we improved this function by substituting the variables and functions with more meaningful names. And we also looked at how we could break down this logic in extracting functions that does one and only one thing. If you do not remember what we covered in part 2, I would suggest that you have a look at the lecture videos and slides on part 2 before getting started with the new content. In today's session, we are planning to deep dive on avoiding deep nesting, avoiding copy-pasting code, and commenting responsibly. We plan to use the same example, the same scenario, the same flow diagram, and the same code examples that we used in part 2. Before we understand how to avoid deep nesting, let's understand what nesting is. In structural programming, when one programming construct is included within another programming construct, this is called nesting. As you can see, the example on the left has a nested if-else structure. The example on the right has a nested while loop structure. It does not have to be the same programming construct. You could have a mix of programming constructs such as if-else structures, switch case structures, while or for loop structures in a nested setting as well. When the level of nesting increases 3, that is known as deep nesting. Nesting is considered as an anti-pattern. The reason is nested code is difficult to understand because of the hierarchical nature. If you look at our lendbook function, you can easily see it contains a nested if-else structure. The nested levels here are 3. Now, technically, it has to go beyond 3 to consider this as a deep nesting. But for the sake of the lesson, let's use this as an example to understand how to avoid deep nesting. If you recall some of the work that we did in part 2, we actually broke this nested structure by extracting functions. This is the improved version of the lendbook function, where we have reduced the nesting to 2 levels. This is one such function that we have extracted out of the lendbook function. This contains the logic which evaluates whether a member is eligible for lending a book. When you look at this function, you would still realize this function itself has a nested if-else structure. This has 2 levels of nesting. We can still simplify this function by removing the nesting altogether. However, to understand how the nesting could be removed, we need to understand a slightly advanced programming concept. Let's learn this new concept by analyzing the flow diagram for this particular function. This is the flow diagram for the function which evaluates whether a member is eligible for lending a book. As you can see, the member ID is passed as an argument to the function, and the function evaluates two conditions using the member ID. It validates whether the member ID belongs to an already existing member, and it checks whether the member has lent more than 2 books. If both these conditions, condition 1 and condition 2, is successful, then the function decides the user is eligible and returns true. If any of these conditions fail, the function decides that the user is not eligible and returns false. Let's break down this logic even further to understand the logical and operation at play here. For the function to decide the user is eligible, both the conditions have to be true. In other words, user must be a member and the user must have 2 or less than 2 books to return. If both these conditions are satisfied, then the user is considered eligible. If the user is not a member, irrespective of whether the user has more than 2 books or less than 2 books, the user is considered not eligible. In other words, if the user is not a member, as in if the first condition fails, irrespective of whether the second condition passes or not, the end result would be the same. Same goes for the other way as well. If the user has more than 2 books to return, irrespective of whether the user is a member or not, the user is considered not eligible. In summary, for the user to become eligible, both the conditions have to be satisfied. However, for the function to decide that the user is not eligible, only one condition failing is more than enough. Let's use this property to rethink our logic of deciding whether the user is eligible or not. Keeping all what we learned in mind, let's have a look at this flow diagram. This is the same flow diagram drawn with the intention of deciding whether the member is not eligible for lending first. The previous diagram was drawn with the intention of deciding whether the user is a member, whereas here the priority is given in deciding whether the member is not eligible for lending. So the first condition, if it fails, the function decides that the member is not eligible, returns false, and ends the function. And if this condition passes, it moves to the second step. And if this condition fails, again, the user is not eligible, the function returns false and ends the function. If it goes to step 3, that means both the conditions have passed. And this means the user is eligible for lending and the function returns true. Now let's try to model this behavior in our logic. So what you see on the screen is the current version of is member eligible for lending function with the nested if-else structure. But looking at the flow diagram that we analyzed earlier, this is the new implementation of the eligibility function. The model or the shape of this function directly represents the flow diagram. it checks one condition. If it is not true, it exits. And then it checks the other condition. If it is not true, exits. And finally, if it comes to that point, it means both the conditions were true. Hence, the function decides the member is eligible. As you can see, it does not have a nested if-else structure. So this is called programming for negation. Rather than checking whether the member is eligible, we write the function with the perspective of checking whether the member is not eligible. And this allows us to break nested if-else structures as well. Let's apply this new technique that we learned to our lend book function, which had nested if-else structure. Again, this resembles the same structure, and we have programmed for negation. This is how the function used to look. This is the very first version. Then we improved it to this level by applying meaningful names and extracting functions. And further, we have improved by programming for negation and breaking down the nested if-else structures completely. Now, this function is quite readable, understandable, and easy to maintain as well. When you're writing code, you will encounter plenty of scenarios where you find some of the already written pieces of code can be reused in other places. For example, look at the return date calculation function. And it's quite possible that within the library management system, the return date calculation is used in multiple places. And since you have already written the code, you should be able to reuse it. How would you reuse it? The easiest way would be to just copy these lines of code and paste it wherever it's required. Even though this is easy, this is the beginning of a series of unpleasant problems in your code base. Now, why is copying and pasting bad? So to start with, let's assume that you have copied the return date calculation logic in 5 places. And if you want to update this logic, let's say you want to increase the number of dates from 14 to 21. Now you have to go to all these 5 places and update the code. This is extra work. The problem becomes even worse if you forget where you put the copy-pasted code. When time progresses, it's natural that you don't remember where the exact copy-pasting was done. And if that's the case, you will find places where the code is not properly updated, which causes bugs in your code. What if someone copies and pastes code without understanding? Although the functionality would work initially, if at all you want to do troubleshooting or modification to that logic, then the lack of understanding is going to create you a lot of problems. Copying and pasting code everywhere, it increases the code base size, which is not a good thing to have. It's okay to increase your code base with valid pieces of code, but the same thing copying and pasted, it's not a proper way of growing your code base. And altogether, this decreases the code readability because you'll find the same piece of logic in multiple places. And in the worst case, you'll find some of these pieces getting modified, whereas some of them retaining as it was on the first day you copied and pasted this code. So what's the proper way of reusing functions? The answer you already know. It's just that you should extract reusable functions rather than copying and pasting the piece of code. In part 2, you extracted out this functionality of calculating the return logic and put it inside a very nice function which holds one responsibility, which is calculating the return date. Now, since this is a function, any other function which wants to get return date calculated can simply call this. So you're not copying and pasting code. It's the same 3 lines, but the function is being called in multiple places. And if you want to edit this functionality, it is this function only that you have to edit, and the change will get reflected in all the places this function has been called. So remember, no copy pasting. If you want to reuse code, extract a function, create a reusable function, and make it readable, and make it hold one and only one responsibility. Let's understand how to introduce comments in a responsible manner. Now, comments are non-executable lines of code, which is there to elaborate the code a little bit better with the intention of increasing the readability of the code. So let's look at this example. So this is the very first version of the lent book function, which you all understand was not that great. And in part 2 and just before, we together improved this function to look quite readable, summarized, and easier to modify as well. Now, while it's possible to improve this function further so that the function itself is talking about what it's going to implement, why do we need to write this much of comments? If you look at the comments, the comment is quite elaborate. It explains what the function does perfectly. But the problem is the developer has given priority in writing a comment versus improving the function. And this comment, therefore, is not justifiable. The other problem with this is, since the logic is completely explained in the comment, if you change the logic in the function, you must update the comment. If you leave the comment as it is, the comment becomes outdated and the reader would get completely confused. As you saw in the previous example, commenting code could be an anti-pattern or could be a bad practice if you don't do it right. So these are some do's and don'ts in commenting code. If you want to properly comment your code, make sure before writing the comment, your code is self-explanatory. Now, all these techniques that we are learning in terms of introducing meaningful names, avoiding nesting, extracting functions with single responsibility, they are all for making your code self-explanatory. So first do that. And if you write comment, make sure the comments explain the intent of the code and use it to clarify the code a little bit better if you feel that you have improved the code to the fullest extent. And you can also use comments to indicate certain warnings or consequences, things such as certain business rules that the code cannot directly speak of. Things that you should avoid at all costs is not to just comment the obvious or just add comments for the sake of increasing the lines of comments or to give the look and feel the code is commented very well. And it's always important to understand, if you want to remove some code, don't comment it. If you have decided to remove the code, just remove it. Don't leave commented code in your code base. And finally, don't use comments to describe what you should have done in the code. That's pure laziness. If you want more time, negotiate and get more time and improve the code rather than commenting and saying, this should have been done in a different way and we are going to do it in the future. And one thing that you need to remember and keep on practicing is, whichever the comments that you introduce, they must be updated if the code that the comment refers to gets updated. Otherwise, your comments become outdated and the reader will get utterly confused. Here are some examples of bad comments. This we looked at. While the capability of improvement is there, the developer has decided to just comment things out. The developer has decided to introduce a comment. And this is code which should have been removed, yet the developer has this commented out. This should not be there in the code base. And this is a classic example of the developer letting the reader know things should be done and the developer didn't have time to do it. Not a good thing to do. And this comment doesn't add any value in terms of improving the readability. The line of code is quite obvious. It is comparing whether the length of the books array is less than 2. It does not need any comments to explain that. So this is just noise or redundancy. These are examples of some good and responsible comments. The first one, the comments essentially help the reader understand the code a bit better. And the second one indicates a business rule, which explains why the len time period is assigned number 40. So both of them are concise, yet explains the code a bit more better. And these are quite responsibly done comments. This brings to the end of our lesson. So let's conclude what we've learned. We learned 3 techniques: avoiding deep nesting, avoiding copy pasting, and commenting responsibility. Before we end this lesson, let's have a look at the 4 main qualities of a clean code base: readability, maintainability, testability, and extensibility. Now, since you have looked at some examples, you would have realized making the code more readable automatically makes it more maintainable or more testable as well. This proves these qualities are interconnected. If you improve one quality, the other 3 qualities automatically improve. And it goes the other way as well. If you're degrading on one quality, let's say you are degrading on readability, the other 3 qualities would also go down. Therefore, make sure that you understand each of these qualities better. Now you have a platform in understanding how to write readable code. Use this platform and use some of the references that I have provided in the lecture notes to understand the other 3 qualities a little bit better and keep on practicing these techniques. Finally, clean code is the way to go. Thank you very much for taking part in going through this lesson with me. I hope you have gathered a lot of knowledge. Keep on practicing them and become good developers. All the very best in your future endeavors. Hello.